A robotic gripper is a end effector, so it's something you put on the end of a robot arm that helps it pick up whatever item you may want it to pick up. So the one that we've developed here is a universal gripper, so it can pick up many different items with the same gripper. The design of the gripper is very simple. It has two main components. One is this massive granular material, and we find after quite a bit of research that coffee has worked very well for us for that massive granular material, and that's encased in an elastic membrane. And for this prototype we're using a latex balloon for that membrane. And so what happens then is you can control the pressure inside the balloon, and if you evacuate the air from the balloon, it'll contract very slightly and the coffee will become vacuum packed and become very hard.
So this is a prototype of what this gripper looks like. What you basically have here is a party balloon filled with grains of coffee. And why did we choose these materials? It's basically, you know, if you've ever handled vacuum packed coffee, you know, it's as hard as a brick. But once you release the vacuum of that package, the coffee spills like a fluid. So this is what we call the phase transition between solid and fluid. We've seen it in water and ice. It's exactly the same phenomena here, but instead of atoms of water, molecules of water, we have grains of coffee.
We tried rice, we tried different seeds and beans and many different things, and we found that coffee was a very good material to use because it was irregular, so the grains did kind of interesting things and locked into each other really good when it was driven into the jamming state, that rigid state.
You know, the big leap that we've done in this project, led by Heinrich Jaeger from Chicago, was to realize that this very fundamental process can be used in robotics, and I think that's you know that's the big step. Once Heinrich realized this, then it was a question of how to apply it, the different ways, what materials work best, and so forth. You know, this is one example of applying this concept to manipulation, but you can also imagine other applications. You can imagine, for example, structures that are soft when they need to be, they can reconfigure and then harden when they need to. So reconfigurable structures. You can imagine putting this kind of structure on the feet of a robot so that it can walk on the wall or on the ceiling and grasp things as it's walking. You can imagine putting these kinds of things on robotic tracks, on fingers. So there's really lots of ways that this kind of technology can be used, and we want to see where it can take us.